Yeah, I'm having fun. I hope you're having fun going through all these past questions. Now we go back to JAMB. At JAMB 1987. A constant force of 40 Newton acting on a body initially at rest gives an acceleration of 0.1 meter per second squared for 4 seconds. Full stop. Calculate the work done by the force. Let me take it again. Now I will want to read meaning into this. A constant force of 40 Newton acting on a body initially at rest. Once you hear initially at rest, or once you hear that a body is at rest, know that the initial velocity must be 0. Then it says gives an acceleration of 0.1 meter per second squared for 4 seconds. Calculate the work done by the force. Options are A, 8 joules, B, 10 joules, C, 32 joules, D, 160 joules. This is JAMB 1987. Let's go. First of all, we bring out all known parameters. All right, a constant force here is 40 newtons, and then initial velocity is 0, then acceleration is 0.1 meter per second squared, and then we have time 4 seconds. We have that our time is 4 seconds. Now the question is calculate the work done by the force, and you always state the equation. Work done is force times distance. Remember we said always work from known to unknown. In this our equation now, work done is unknown, force is known, and then distance is unknown. How do we do it? That will now take us to equations of motion, because we have initial velocity, we have the acceleration. Now we go back to which of them will help us. We go to the third equations of motion, the third equation of motion, and that says that S, the distance, is equal to initial velocity u t plus half a squared. So we have that S is equal to ut plus half at squared. That's the third equation of motion. Third equation of motion. Distance is equal to ut, but u here is 0. If u is 0, u here is 0. If u is 0, this aspect of it is 0, leaving us with distance being equal to half at squared, which is half times 0.1 meter per second squared times the time 4 seconds squared. And this will give us, when you calculate it, we are going to be getting, we will get 0.8 meters. So distance now is 0.8 meters, and then work done is now equal to force times distance, which is force is 40 newtons, times distance, which is 0.8 meters, 0.8 meters, and then work done is 40 newtons times 0.8 newtons, and it will give us 32 joules. So the correct option here is option C, 32 joules. Option C. The next question will be taken, we go to WAEC 2000. WAEC 2000. The question says, a machine of efficiency 80% is used to raise a body of mass 72 kilograms through a vertical height of 3 meters in 30 seconds. Full stop. Calculate the power input. Calculate the power input. And we are asked to use G to be equal to 10 meter per second squared. Remember, you always read meaning into the question. First of all, you ask yourself the formula for efficiency when it comes to machines. Formula for efficiency. And efficiency is power output all over power input times 100%. That is efficiency. So we go back quickly. We clean here because to take us to this place. So we go back to say that efficiency is equal to power output all over power input times 100%. That is efficiency. Now, efficiency is known, power output is known. Is it known, or we are going to work it out? We work it out, but we have parameters that will help us to work it out. And then the input is unknown. So when we make power input the subject of the formula, we make okay, let us just expand. Bring out our parameters first. When we bring out our parameters, then we will now go about doing this. So efficiency is 80%. Efficiency 80%, that is efficiency. Then power output. Power output is equal to the mass times gravity times height. So let us bring out the parameters that have been given to us. We are given the machine has the mass of 75 kilograms. So the mass is 75 kilograms, the mass of the machine, and then the height is 3 meters. Height is 3 meters. 3 meters. That's height of 3 meters. And then the work is done over 30 seconds. So the time is 30 seconds. Now, the power output now is mgh. mgh all over time. That's the power output. mgh all over time. So power output is mgh over time, which is 75 kilogram times 10 meter per second squared times 3 meters all over 30 seconds. So when we calculate this, if we calculate this, we are going to have 75 watts. We have 75 watts. We already have the power output. So what do we do next? We make power input the subject of the formula, and when we make it the subject of the formula, it becomes power output. Power output over is now going to be over efficiency times 100%. It now be power output over efficiency times 100%, which is 75 times 100 all over 80. All right, 75 times 100 all over 80, and this will now give us 93.93 point, calculate it well, 75 watts, 93.75 watts. So this is the answer. This is WAEC 2000, and this is the theory part of the question. Now the next question is from WAEC 2000. A machine of efficiency 80% is used to raise a body of mass 75 kilogram through a vertical height of 3 meters in 30 seconds. Calculate the power input. And you are giving G as 10 meters per second squared. Let me run it through again. A machine of efficiency 80% is used to raise a body of mass 75 kilogram through a vertical height of 3 meters in 30 seconds. Calculate the power input. G is given as 10 meters per second squared. WAEC 2000. This is theory aspect of the question. Now, we bring out the parameters. That is the first thing you do. Efficiency is given. Efficiency is 80%, and then the mass is 75 kilogram, height 3 meters, G is 10 meter per second squared. What else is given in 30 seconds? So time is given 30 seconds. Now the next thing is for you to write the formula for finding efficiency in machines. Now efficiency, let me shorten it, is equal to power output all over power input times 100%. And from here, where efficiency is known, power output we can say is known in a way because the parameters given to us can help us to find power output. Then we are left with power input. So let's look at power output. We now have power output is equal to mgh all over time, and this is mass is 75 kilogram times 10 meter per second squared times h, which is 3 meters all over 30 seconds, all over 30 seconds. And we now have, when you calculate it, it will give you 75 watts. So when you calculate this, will give us 75 watts. Then we now have the power output is 75 watts. All right, we now substitute into the equation. We have that efficiency is equal to power output all over power input times 100%. And then we are looking for power input. We are looking for power input, which is power output all over efficiency times 100%. We can now substitute. Our power output is 75 watts all over 80 times 100. And then when we calculate, it will now give you 93.75 watts. This is your answer, 93.75 hours. Thank you. Keep reading, keep studying. It's not difficult. When you study, you understand, and bam, it's very easy. I'm telling you the truth. Thank you.